When adding or subtracting polynomials, the first step is to distribute the positive or the negative sign and rewrite without parentheses. After that, we're going to combine like terms. Again, a like term is a term with the same variables and exponents. So for example, I know that 3x and 4x are like terms because they both have an x to the first power. 2 and 6 are like terms because they're both just numbers. So I want to distribute my positive 1. Well, I know that positive 1 is not going to change anything, so I'm going to rewrite this polynomial without the parentheses. I'm going to draw a line connecting my like terms. 3x plus 4x gives us 7x. 2 plus 6 gives us 8. And we've also ordered it in standard form because our highest exponent, which is 1, comes first. In our second example, I'm going to show us a different way of solving that some people might like more than just connecting like terms. So again, we have a positive sign. This is not going to change anything in the parentheses. So I'm going to rewrite this instead as an addition problem where I line things up vertically. I know that 2 take away 5 is negative 3, and I know that 1x squared plus 1x squared is 2x squared. You can use either method, just make sure you're always lining up the like terms. So I lined up my x squareds and then I lined up my numbers. In our third example, I'm going to solve it the same way. So instead of, because we have a positive, again, distributing the positive is not going to change anything. So I'm going to line up everything under the like terms. X is under x, y is under y, z is under z. 2x plus 3 plus 1x is 3x. Y take away y becomes 0. 3z plus 1z becomes 4z. You'll notice that this is also in standard form because I've gone alphabetically. Because x comes before z in the alphabet. In example 4, we have a negative in between our parentheses. This means that there's an imaginary negative 1 outside of this parenthesis that we need to give it to. So I'm going to distribute and rewrite this equation with the negatives. So I bring down 4m and negative 2n. Notice that there's nothing in front of the parentheses, so we just keep it the same. 3m becomes negative 3m because it was positive, and 3n becomes negative because it was positive as well. Now I'm going to connect my like terms. Again, you can use this method or you can stack them. 4m minus 3m is just m. Negative 2 take away 3 is negative 5n. Notice that these are both in, or this is in alphabetical order as well. In our last example, we have a really big polynomial that we're going to need to simplify. I notice in between these parentheses is a positive, which means nothing in here is going to change. This has a negative, however, therefore these things are going to become the opposite sign. So I'm going to put a negative 1 right there. I'm going to choose to stack these because I think it's easier. I'm going to put 2x squared under x squared plus 2x under negative 7x and then minus 3. Before I can put everything underneath for this polynomial, I'm going to distribute my negative 1. I know that 3 times negative 1 is negative 3x squared. A negative times a negative is a positive. A negative times a positive is a negative. So now that we've changed our signs appropriately, I'm going to put all of the like terms underneath each other. We have negative 3x squared plus 5x minus 7. You're going to see that we have 10 take away 3, which is 7. 7 take away 7 is 0. So there's nothing left in this column. Next we have negative 7 plus 2. I know that negative 7 plus 2 is negative 5. Negative 5 plus 5 is also 0. So right now, we're just left with a bunch of zeros. In our last column, we have 1x squared plus 2x squared, which is 3x squared. 3x squared, take away 3x squared, is also 0. So we found that once we combined everything in this polynomial, everything canceled out, leaving us with a value of 0.